Hey guys, welcome to Homework Help for Year 7, Term 3, Week 9. On page 31, we're doing the revision sheet. Question 1. Find the values of the pronumerals in each of these. So Pythagoras theorem, we're going to do a squared plus b squared equals c squared. Here's your a, here's your b, so 8 squared plus 15 squared is equal to k squared, which is your c. So k is going to equal to the square root of whatever you get from adding these two numbers together. And just use your calculator and get it to, is it 1 decimal place? No. Just put it to about 1 or 2 decimal place. Maybe 2 decimal place. Question B. Now this is your, any A and B can be either that, or A could be here, B could be here. It doesn't really matter. Okay. So either way, you can say that d squared plus with 16 squared is equal to 65 squared. So d squared is equal to 65 squared, take away 16 squared. So therefore d is equal to square root of 65 squared, take away 16 squared. Work out whatever number that is and then square root it. Next one, I can say straight away n squared is equal to 58 squared minus 41 squared. So therefore n is equal to the square root of 58 squared minus 41 squared. By the way, this does not equal to the square root of 58. Actually, sorry, not square root. This does not equal to 58 minus 41. Okay, the square root does not cancel these out. It doesn't. So you have to do the working out for whatever this is and then do the square root to get n. Question 2. Which of these are Pythagorean triads? Now the word Pythagorean triads, sometimes they're called Pythagorean triples, which is what I said before. So it's just different naming, but it's the same thing really. Now you have to recognize whether these are the three numbers. Now you can, if you're good at remembering, you can recognize that this is not the case. Remember, it's 5, 12, and 13, not 14. So this will not work. Or if you don't remember, you can do 5 squared plus 12 squared should equal to the longer side, which is 14 squared. And test it if it's true, if they do equal to each other. 5 squared is 25, 12 squared is 144, and 14 squared is 196. So when you add these together, you're going to get 169 equals to 196, which is incorrect. So therefore, this is not a Pythagorean triad. Now, next one. Okay, so this one looks like we got big numbers, right? But however, if I simplify this, I can say this is, if I divide everything by 10, I get this. I get 3, 4, and 5. Now we know 3 and 4 and 5 is the Pythagorean triad. So 30, 40, and 50 must also be Pythagorean triads. Okay, so this will be 3 times 10, this will be 4 times 10, and this will be 5 times 10. So everything has been multiplied by 10, which means the triangle has been expanded by a factor of 10. If the triangle is being expanded by a factor of 10, it should still be a right angle triangle. Okay, so it doesn't matter if I multiply by 10 or even if I multiply by 6, okay, and I get something like 18, 24, and 30, this is still a Pythagorean triad or triples. Okay, as long as you can simplify these numbers and get 3, 4, and 5, then yes, these numbers make up a right angle triangle. Now 6, 8, and 11. Alright, if we divide this by 2, you're going to get 3. Divide this by 2, you're going to get 4. The next number should be 10. If we divide it by 2, we should get 5, but it's 11. So I don't think this is not a Pythagorean triad. Now next one, it looks like they're all even numbers. This divided by 2 gets 7. Divided by 2, you're going to get 24, and divided by 2, you get 25. Yes, we know that 7, 24, and 25 is indeed a Pythagorean triad, so therefore this must be a Pythagorean triad as well. It's just been expanded by a factor of 2. Still right angle triangle. Question 3. Find the width of rectangle with length. Okay, so you got, let me just draw this rectangle real quick. Don't know why it does that sometimes. Just doesn't connect. Here we go. Rectangle. Great. Alright, so we have the, it says find the width, so we don't know what the width is. With length of 18.2 centimeters. And diagonals is, diagonal is 21.4. So I can use these now. This is a rectangle, which means that this is a right angle. All of the sides are right angle. Okay, and you can see here we have a right angle triangle. Okay, so we can use the Pythagorean theorem. I can say that w squared plus 18.2 squared is equal to 21.4 squared. So therefore, if I take away 18.2 squared from both sides, I'm going to get w squared is equal to 21.4 squared, take away 18.2 squared. So therefore, w is equal to the square root of 21.4 squared, take away 18.2 squared. Now do this first. Work out what that number is, and then do the square root. Okay. Next we have find the values of x and y. Lengths are in centimeters. Okay, x. So I can find out x using the Pythagorean triples. I know that there's a Pythagorean triple of 5, 12, and 13. I've got 13 as the longer side, 12, this must be 5. Now if I have that as 5, I can use, what else can I say? Okay, I can use maybe this one here. I can say, alright. Now this is also Pythagorean triad, but it's hard to recognize it. You have here is 3.5. I don't like this 3 point. Let's double it, make it a whole number. Let's see what we get. If I double it, I get 7. If I double this, I must double this. And I double this, I get, what is it? 24. Now I know that there's a Pythagorean triad of 7, 24, and 25. So if that's 24, then this must be 25. So if we multiply y by 2, we should get 25. Okay, because everything else is multiplied by 2. So if y multiplied by 2, we should get 7, 24, 25. Right angle triangle. Now if 2 times y is equal to 25, therefore y is equal to, we half of that. Let me just rewrite that over here. So therefore y is equal to 25 divided by 2. Now equal to 12.5 centimeters. Done. Next page. Question 5. Find the values of each pronumeral. Answer correct to one decimal place where necessary. Okay, let's look at the first one. I can just divide this into a right angle triangle and a square. This is your square and right angle triangle. Okay, so we know this length here must be 12. And what's this length here? Let's see. We have, this is 21 and this is 12. 21 take away 12. And I believe that should be 9. Okay, can you recognize the Pythagorean triad here? 9 is equal to 3 times 3. 12 is equal to 3 times 4. Here you have 3 and 4. So this last one must be 3 times what? Remember the Pythagorean triad of 3, 4, and 5? If this is 3, this is 4, this must be 5. So therefore this is 5. Okay, so k is equal to 3 times 5. So k is equal to 15. Alright, next one. You have here is, let's look at the right triangle first. You got 8. You got some length there. Let's find out what that length is. Now it looks to me like these two triangles are exactly the same, which means they got the same length here. They got the same length there. Okay, they both have 90 degrees. So therefore this length here must be the same as this length. Let's call it x. Alright. So we got 32 from here to here, that's 32, and we got here is 12. So let's say 32 take away 12, and that will give us 20. So these two must add to 20, so x plus x must equal to 20. So therefore that's x plus x is 2x equal to 20, so therefore we divided both sides by 2. X is equal to 10, so this must be 10, this must be 10. Okay, that makes sense. So x, so that's alright. I'm just gonna get rid of all this. Hold on. Okay, so this is gonna be 10. This is gonna be 10. So let's look on the right. This triangle on the right here. So you have this. I'm gonna redraw this triangle. Whoops. Don't know why this is happening. You got 8 and 10. Now remember the Pythagorean triad of actually no, this is not the Pythagorean triad. No, it doesn't work. Alright, so in this case you're gonna have to, because if I divide this by 2 I'm gonna get 4. If I divide this by 2 I'm gonna get 5. We don't have a Pythagorean triad of 4, 5 and a number here. It's only 3, 4. We only have the 3, 4 and 5. The biggest number has to be the 5. But in this case, the biggest number is not the 5. Okay, the biggest number is something else. So therefore, this is not the Pythagorean triad. So we have to use Pythagoras theorem and work it out. We can say, okay, let me just get rid of all this. I can say that 8 squared plus 10 squared is equal to, this is y, is equal to y squared. So y squared is equal to, this will be 64, this will be 100, it'll be, so 64 plus 100 is 164. Alright, so therefore y is equal to the square root of 164, and you can use your calculator to get correct to 1 decimal place. Next question, here we have, this triangle is an isosceles triangle. Right, and I can tell that because this length is equal to this length. Now, when you draw a line from the top of the triangle to the base, you're going to divide this length into 2. This happens with isosceles triangles. So therefore, if this is 16, then this must be 8. Okay. So let me just focus on the triangle on the right. So I got here is 8, I got 10, so really the triangle looks like this. Wait, what? Okay. So we have 10, we have 8. Now if I divide this by 2, I'm gonna get 5. If I divide this by 2, I'm gonna get 4. Now we know there's a Pythagorean triad of 3, 4, 5. Okay, so that means that if this is 5, this is 4, this must be 3. Now so let me just rewrite this. So 10 is equal to 2 times 5. 8 is equal to 2 times 4. So this one must be 2 times 3, and that's going to equal to 6. So the height, we found the height h is equal to 6 centimeters. Alright, next one. Mary walks due west away from school at a speed of 3 kilometers per hour. So due west, so remember the directions we got. I'll just draw real quick here. Never eat soggy wheat. So due west, so she starts here, she goes west. And she goes at a speed of 3 kilometers an hour. Her friend Margaret, so this is Mary. Her friend Margaret walks due north. Oh, due north, okay. Let me move this down. Wait, what's going on? Okay, so her friend Margaret is going north at a speed of 4 kilometers an hour. This is Margaret. And we know this is 90 degrees. Okay, so one goes at 3, one goes... How far apart are the two girls after 90 minutes? So let's have a look at Mary first. She goes at a speed of 3 kilometers an hour. And 90 minutes is 1.5 hours. Okay, so 90 minutes. So after 1.5 hours, to find the distance she traveled, distance is equal to the speed times time. That's equal to 3 kilometers an hour times it by 1.5 hours, 1.5 hours, and that's going to give you 4.5 kilometers. Now Margaret has a speed of 4 kilometers an hour, and she also travels for 1.5 hours. So therefore, it's 4 times 1.5 kilometers, and that's 1.5 hours, and that's going to give you 6 kilometers. Okay, so we have Margaret is 6 kilometers. She's traveled 6 kilometers, and Mary has traveled 4.5 kilometers. Now the question is, how far apart are these two? So let's call that x, the distance x. So to find x, we're going to use Pythagoras theorem. We can say, if I times it by 2, we get 9, 12. 9 and 12. Oh, actually, I guess, okay. I just figured out something here. If I multiply this by 2, I'm going to get 9. If I multiply this by 2, I'm going to get 12. Now we know that if we have a triangle, whoops. If we have a triangle that is 9 and 12, we know this one is going to be 15. And the reason I know that is because of the Pythagorean triad. This is 3 times 4. This is 3 times 3, so this must be 3 times 5. Okay, so 3, 4, and 5, so that must be 15, right? So now this is not 12, this is half. So if we half this, if we divide this by 2, we get 6, like that one there. If we divide this by 2, we get 4.5, and therefore we must divide this by 2 as well to get the length of x. So that would be 7.5. Now, if any of that stuff confuses you and you don't understand how this relationship between the Pythagorean triad works, then just do the using Pythagoras theorem. Okay, theorem. So let's just redraw that triangle again. Okay, and you have here 6, you have 4.5. and with his x. So therefore x squared is equal to 6 squared plus 4.5 squared, and that's going to equal to 36 plus 4.5 squared. Let me check what that is. That's 20.25, and that's gonna, if you add them together, it's gonna be 56.25. So therefore x is equal to the square root of 56.25, and you will get 7.5. Same thing, and this will be in kilometers. So that's the same as what I got here, 7.5 kilometers. Okay, that's distance, how far apart they are from each other. Alright, next one, question 7. The figures are a bit messy. I'm going to rub this out. Can't see here clearly. And let's get rid of this. There. Alright, the figure is a rectangular prism. Find the value of y corrected 2 decimal place. The value of y. Now to find, so I'm going to redraw this triangle real quick here. Okay, so that's the triangle there. We need to find y. So let me just move this triangle over to here, so you can have so you can see. Maybe if you enlarge it a little bit, and actually leave it same size. Okay. So we know this is 6 given to us by this. We don't know what this is. We need to find this out. And to find that length there, we need to use Pythagoras theorem for this triangle. So we have, let's call that x. Okay, I'm going to redraw this down here. Okay, this is also a right angle because that's a right angle there. This is 9, this is 8. So I can say x squared is equal to 8 squared plus 9 squared. X squared is equal to 64 plus 81. X squared is equal to 145. So therefore x is equal to the square root of 145. Let's leave it like that for now. Okay, so we know, and this is your x here, and this is your y. So we know that x is equal to the square root of 145, so I'm just going to rewrite this, the square root of 145. Okay. Hey Google, send Jarvis to the dock. Okay, so now we need to find y. Excuse me. Sorry about that. Alright. So what we're going to do is, this is a right angle triangle here, the blue one. And I can say that y squared is equal to 6 squared plus the square root of 145 squared. So therefore y squared is equal to 36 plus with, when you square a number that's square root, you're going to cancel out the square root and you're going to get 145. So therefore y squared is equal to, what's this? It'll be 100 and I don't know what's, okay, this will be 11, this will be 8, and it'll be 181. So therefore y is equal to the square root of 181, and you get the answer. And put it to 2 decimal place. Alright. Moving on to the next page. Extension questions. Find the value of x, y, and the length CD. To find x, well, this is not too hard. I can see this is going to be 6 straight away. Okay, and the reason I know this is because if I divide this by 2, I get 5. I divide this by 2, I get 4. So if I divide this by 2, I should get 3, isn't it? 3, 4, 5, so 6, 8, 10. So that must be a 6. It's just similar to this. It's just similar to this triangle here. You got 3, 4, 5. So this will be 6, 8, 10. Okay, this is the Pythagorean triad. Okay, so I can tell that 6 straight away. Now, I need to find out this length y. So this will be, so the answer here is 6 for the first one. Now y. We have 8, 14. Okay. I think there is a Pythagorean triad for 8 and 14, but I can't remember what it was. So I'm just going to work it out normally. So I'm just going to say, okay, 14 squared is equal to 8 squared plus y squared. So that's minus 8 squared from both sides. So y squared is equal to 14 squared, take away 8 squared. So y is equal to the square root of 14 squared is 196, 8 squared is 64. What's 196? Take away 64, you're going to get 2, you're going to get 332. So therefore y is the square root of 132. And that's going to be 11.49. Let me just double check the working out for this one. 14 squared, take away 8 squared. Yeah, 132. And that's correct. Alright. So this will be 11.49. Now, to find the length CD, which is from here to here, it's gonna equal to y take away x. So you can work that out. CD is just the length of y, take away the length of x. There, and you will get the remaining CD. Okay, question 9. Name each of these solids. Okay, you can do that on your own. Question 10. Which of the solids in question 9 are prisms? Now remember that prism is basically you have a shape and then you extend that shape parallel all the way to the other side, and that's a prism. So for example, A is a prism, that's a cube, and that's also a prism. Let's see another one. Maybe this one is also a prism. You got a triangle that extends parallel, all the edges, all the vertices are extended parallel to the other side, and that's another prism. So you could say A, B, C. These are all prisms. Now D, you have a circle and you extend it down, and you have another circle. Now this is not a prism, because the definition of a prism is that the base, or whatever shape it is, it has to be a shape that is that has to have straight lines. Okay, and this has a curved line, so it doesn't count. This has its own name, cylinder. That's why we don't call this a circular prism. It's just called a cylinder. So that okay, B, pyramids. Now pyramids have a point called the apex, and that's the point where at the top of everything, and it's a vertex that connects all the other vertices together. Okay, so you could say G is one and H is another one. Now E, this has a point where it connects all the vertices, but you see the base here is a circle. Okay, for a pyramid, the base has to be using straight lines as well, and this one doesn't have it, so therefore E is not, this one is not a pyramid. That's why we don't call this one a circular pyramid, it's just called cone. It has its own name. Okay, now the question C, polyhedral. Polyhedrals are shapes that are made up, are 3D shapes that are made of polygons. What's a polygon? Polygon is just any shapes with straight lines connected and is closed. So that's a polygon. This is not a polygon. Okay, so if you have a closed shape and they're done using straight lines, then that's a polygon. So which of these figures are polygon? Well, this is one of them. So you can say, for example, A is one, B is another one, C is another one. This has curved lines, so we don't count. This has curved line, this is not, and you can say G and H. These are all polyhedrals. Okay, next page. Question 11. Draw an oblique cylinder and a right circular cylinder. A right circular cylinder is just a regular cylinder, so that's just another word for cylinder, a normal cylinder. And draw an oblique cylinder, so draw two types. Now, an oblique shape is a shape where, imagine if you have, for example, a pyramid. Looks like this, right? Usually, the apex, the top of the pyramid, if you draw a line that's perpendicular down to the base, it's gonna be hit the center of whatever shape the base is. But with an oblique pyramid, okay, let me just redraw that. With an oblique pyramid, the apex, the top, when you draw a line down, it doesn't hit the center, it hits at some other point. So it's kind of like the pyramid's been slanted, it's been pushed to the side, something like that. Okay, so now you're going to draw an oblique cylinder. So a regular cylinder looks like this. Whoops, I should probably draw on this side. An oblique cylinder looks like this. It's just been kind of slanted. Yeah, like that. Question 12. State whether each of these solid is convex or non-convex. Now, the word convex, imagine if you have a polygon like this. I'm going to explain what this means. Actually, I should probably draw it properly. Hold on. Oh, no, that didn't work. Okay, imagine those are straight lines, and you have another shape that looks like this. Okay, so what we do is we take the shape, this polygon, and we just extend the sides. Now, if you extend the sides and the extended side doesn't go inside of the shape, this is known as convex. Convex shape. But if you extend the sides, let's look at this one here. Let's extend this side. Extend all the sides. Okay. But this one, when you extend this line, it goes inside the shape. So now this one is not a convex. This is actually called concave. Concave shape. So, which of these solids is convex? If a solid is convex, that means that the one of the faces is gonna look like this. It's gonna be like this. All the faces should be like a convex shape. Okay. Whereas non-convex shapes, that means that at least one of the shapes is not convex. It's concave. So let's look at this one. Is this one? You can see the base here. You can see that base is looks like that shape. Now, is this shape convex or concave? Well, if I extend this line, I'm going to color this in blue. It goes inside, okay, the shape. So this is concave. This is non-convex. And you can see this one here is convex, because if you extend all the sides, it never goes into the shape. It only goes outwards. Alright. Question 13. What is a frustum? Now, a frustum is if you have, let's say you have a cone. And let's say I cut this cone parallel to the base of the cone. So it looks like this. So now I cut this part off, it's gone. So let me just rub this out. This is a bit... So now the shape looks like this. Whoops. Alright, there you go. Where this face is parallel to this face. They're parallel, okay? This is called a frustum. It can happen also for, let's say, a pyramid. You cut this pyramid, it'll look something like this. Okay. Now, question 14. Explain why a cylinder is not a frustum. Well, a cylinder, if I take a cylinder and I cut it, alright, parallel to the bottom, I'll just get another cylinder. It's not a new shape, it is the same shape. It's still called cylinder. So a cylinder is not a frustum. So no matter how many times I cut it, it's still gonna look, it's gonna be another cylinder. Okay, whereas when I cut this pyramid, I get a new shape, and that new shape is called a frustum. Same with the cone. Okay, question 15. What are skew lines? Okay, so skew lines, let's imagine if we have 4 planes, 3D shape. Okay. Alright, imagine if you have a piece of paper, and on this piece of paper I draw a line. And then I draw another, and now I draw another line, but it's not on the piece of paper, it's actually going like something like this. Okay, you can imagine this like a 3D shape. Here's a piece of paper there. You draw another line, but this line goes on a different plane of existence. It's not even on the same plane. So these are called skew lines. Those two are skew lines. Question 16. Name 2 edges of this prism that are parallel to TU. So let's look at TU, which is this one here. You can name any 2. So for example, you can say PQ is one of them. Another one could be, another edge could be WV, another one. Now we'll do another one for perpendicular to RV. Whoops. RV is going to be, where is it? RV, this one here. It says perpendicular lines that to RV must meet it at 90 degrees. I can say this line here, so we can say WV is perpendicular to RV. So that's another one. Okay, you can name a few, just name 2. Let's see, skew. Question C, skew to SW. SW, I'll put in blue. SW is this one here. Now skew means that it's not on the same plane of existence. So imagine if it's there, that means that the plane of existence could be, let me see. For example, PQ. Okay. It's not even on the same, it's not in any of these, it can't be any of these lines. Okay, so PQ is on the other side and it's like pointing in a different direction. So this you can say PQ is one of them. Another one you can say, we can't say for example WV, because maybe this line SW might line on this plane. Maybe it's on this plane, and this is on the same plane. Okay, so we can't say any of these lines connected to it. We can say probably another TU is another one. You can say that. All right, next one, question 17a. What is Euler's formula for polyhedrals? Now Euler's formula is written as V minus E plus F equals to 2. Okay, and this is, V stands for the number of vertices, E stands for number of edges, and F stands for number of faces. Okay, now question B says verify the formula for each of these solids. So let's try for the hexagonal prism. Now hexagonal prism is a prism that has, the base has 6 sides because it's a hexagon. So it looks something like this. Okay. I'll just draw the backing. Alright, now I'm gonna we have to use Euler's formula to verify if it's true using this shape. So let's use Euler's formulas for this shape, see if it's true. V is number of vertices, so how many vertices does it have? It's got 1, 2, 3, 4, 5, 6, and down here we got another 6, so that makes 12. Okay, so we have 12 vertices minus number of edges. How many edges we got? 1, 2, 3, 4, 5, 6. 6 on the top, 6 at the bottom, and we got 1, 2, 3, 4, 5, 6. 6 on the side. So 6 plus 6 plus 6 is 18. So let me just get rid of that. So that's 18. And then we have to plus the number of faces. How many faces we got? We got 1 top, 1 bottom, that's 2. And we got 6 on the side. 1, 2, 3, 4, 4, 5, 6. Okay, so that'll be 6. So let me just get rid of that. And that's 6. Alright, let's see if it's equal to 2. Is that equal to 2? Well, 12 minus 18 is negative 6. Oh, sorry. The number of faces should have been 8. I forgot to add the top and bottom one too. So it'll be 8. Because you got 1, 2, 3, 4, 5, 6, 7, 8. So it should be 8. Yes. So therefore, 6 minus 6 plus 8 is indeed 2, which means that Euler's formula works. Now we're going to do the same thing for the decagonal pyramid. Deca means 10, so a 10 with a pyramid with 10, the base having 10, what do you call it? Sides. I don't know how to draw that, but something like that, and it's just connects to that. All right, so let's try it out. We're going to use this one here. Number of vertices. Well, we got 10 at the bottom and 1, so that's 11. 10 at the bottom and the apex at the top, yes, it makes it 11. Minus number of edges. Well, we got 10 at the bottom and then 10 that goes to the top, so that's 10 plus 10 is 20. Now we do number of faces. Okay, how many faces do we have? Well, we got 10 faces for each side of the of this pyramid, plus the bottom face. So that's 11. Huh? Hold on. Plus, is that 11? Yeah, that's correct. So this is minus 11. So 11 minus 20 is minus 9. Minus 9 plus 11 is equal to 2. So again, it works for Euler's formula. There you go. All right, next page. Name the 5 Platonic solids. So the Platonic solids are solids with all the faces. All the faces are identical, or we can call it congruent. So for example, a cube is 1, tetrahedron is another one, and I'll give you another. It says name 5. Okay, I'll show you the other one with a picture, and you can just write them down. Question 19. Draw a net for each of these solids. Okay, so these are pretty basic, so I won't do these. And then I think that's the end of it. Yep. Okay. All right. Hope that helps.